So it's kind of like a yes and no question. Theoretically, traveling into the future is easy. All you need to go is really fast. So if you go a significant percentage of the speed of light, then Einstein's theory of relativity says that time will
Yeah, but
travel slower for you than it will for the people who you're traveling fast relative to. So for example, if you went at, for example, maybe 80% speed of light away from Earth, they would age much more while you would age only a little. And if you were to go at 100% of the speed of light, the effect would be down to almost none. So like almost no time for you would be a really significant time for the people on Earth or who you're relative to. But the problem is that only really applies to if you're going into the future. If you're going into the past, it's much harder because there are a few theories that things like wormholes exist that connect two folds of space-time so that theoretically you could go through one end and maybe end up back in time, but overall it's just really difficult and it requires a lot of complex math and technology we just don't really have yet. So going into the future, you do it all the time when you go on an airplane. When you go on an airplane and you land, you're a really short period of time younger than the people back on Earth. Like I think it's 5 nanoseconds or something. That's how much younger you are than the people on Earth. So
But
yeah.
but I feel that's not more like time travel. It's like trying to stop time for a few seconds. That's all.
It's like
But
time dilation, right?
yeah,
Time
time
dilation.
delay.
that is time dilation, yes.
Time
Yeah,
dilation.
yes,
You know,
but
because time
but
dilation and time travel is different.
no,
Like
but time
one,
travel, you are traveling forward in time. Like they said, more time passed for the people on Earth than it did for you. So when you land, you've traveled 5 nanoseconds into the future. And it's the same thing with the people on the International Space Station. There's a very interesting thing. Two identical twins. They both spent time in space, but one spent more time than the other. And when they both came back to the ground, the one that was in space, the one on the ground was 5 milliseconds older than the one in space on the International Space Station.
But how can you say?
Theoretically it's possible, but we have to invent a device that goes to the speed of light if we want to travel to the future. And again, most of us would rather travel to the past rather than the future, I think. So yeah.
I've heard one news that China had made one super flight, but it is only faster than the speed of sound. Reaching the speed of light is very difficult, and if we could make it also, we need like more than 10 times of that energy so that we can exceed it. Otherwise, we'll just have like 5 milliseconds or 6 milliseconds. We are younger than the previous people on Earth.
Yeah, like if I'm correct, I think the International Space Station is going at around 17,000 kilometers a second in orbit. If any of you know, please correct me, but I think it's that. And still they only age 5 milliseconds. So you can imagine how fast you need to go, but you don't need to go at the full speed of light. You just only need to go in a significant fraction to go to age. But basically the faster you go, the less time passes for you and the more time passes on the object that you're moving relative to.
I think traveling to the past is not possible because of the grandfather paradox, in which just imagine that you make a time machine and go back in time and kill your grandfather. Then your father will not want. So how will you kill your grandfather in the first place? So maybe traveling to the past is not possible.
but there's another theory that what if you going back in time to kill your grandfather was always written in your past, and
You know
all
what?
of and all of that led up to where you are right now. Every moment in your life before led you to this point where you went to go back and kill your grandfather. So maybe it was always written in past. That's another theory
kind of
that
like
counters the
Yeah.
grandfather paradox.
I would want to say that if you kill your grandfather, actually you will also disappear. Because if your grandfather didn't exist, then your mother wouldn't have existed or your father wouldn't have existed, then they wouldn't have met
Then,
each other and you wouldn't have been born. So basically, if you kill your grandfather, it's your own loss. You will only die.
no,
You will
not
die.
like
How?
that, because
How will we
it's
die?
like we are
Because
going to a
you
point
won't be
of-
born only, so you will disappear.
No, we are going to time travel means we are going to a space of time, a space of time like that. So if you kill your grandfather, it's not gonna work like that. You came, it's not gonna work because you know that thermodynamic law to second law which states that entropy should increase, but when you go to past, it's not increase. So many things which cannot happen, and time travel is not possible. I think, of course, we need a vast energy, and there's negative energies. That
But
there are many conception theories. You cannot that now it's not possible like that. Maybe in future, maybe like energy should be. We should have more energy. Like
but the main reason is that mostly the simplest answer you'll find whether time travel is possible or not is that they'll always show no, because the main thing of time travel is that it is forbid the laws of physics. It goes against the laws of physics, so it doesn't work.
and I think time is really. I think time doesn't exist. It's like an illusion. Take like measurable period during which an action process like an thing a
Like
concept of human beings to I think so like that for stating anything or what happened when like that I think so for that time was created. So I don't think so. It does actually time is created by human. So time is not time is also irreversible. Then no chance. Like,
Could I add something? Pranav, you're actually wrong. Time travel doesn't go against the laws of physics. Going into the future, like I said, was using relativity, which is a well-known and
back, going in past, what about that?
going to the past. There are a few theories that could let you go into the past. Like there are two I think currently there are two supermassive black holes that have not merged yet, and they're just orbiting around each other. And if you were to go there in the correct trajectory, you could get teleported back in time to where you started. And there are other things like wormholes, for example.
Wormholes is completely fictitious, is what I feel.
no, we cannot say that.
No, we can say that. No.
That can,
It's not fictitious.
Wormholes can exist.
Okay,
Yeah,
then
like
can you give me an
Einstein-Rosen bridge,
example of a wormhole?
no,
I think it's
They're
like
said to be really,
Einstein-Rosen
really
bridge.
small.
Isn't it just a theory? Just a theory.
it's a theory, but
It's
just
a theory,
but
but
just
it's the most.
just a thing being a theory doesn't mean that it doesn't
Everything-
exist.
But it can also be that if it's a theory, it cannot exist also. Like right now, whatever theory is there of time travel is possible, I can say it's just wrong because it's not happened. Is there a single experiment that has proved time travel is possible?
The
And
one
that's what a theory is. We don't know if it's true or false. It's
Yeah,
just something we are
exactly.
believing in.
but it's time travel has happened. I said like on the airplane with the International Space Station. It's small, but it is time travel. And if you do go faster, you will travel into the future. The past is harder, but time travel is possible and it's already happened.
So
what-
I don't believe time travel into the past is possible right now, but time travel in the future is possible under certain conditions. And if we are able to achieve the speed of light, then time travel may be possible for us. Actual
Okay,
time travel.
sometimes, okay, you assume that there's an object which can go faster than the speed of light. What do you think is most likely to happen?
If I say from my possibility, it may be able to like time travel through different dimensions, and it will be able to reach anywhere in even before we won't be able to even blink our eyes.
I think nothing will happen.
If we travel in speed, nothing will happen. We cannot say. There are possibilities. One, we can time travel. Other one is that we can destroy Earth. We may be able to destroy Earth by that.
How?
Eh?
How?
If you go bit too like a lot faster, like the air surrounding you are getting pushed even faster than the light, so they apply even more force. When they apply even more force, so if you apply force to anything, it will push, right? Imagine the force was like into thousands, that thing will get destroyed. So if it's going more than a light speed, anything on its path or surrounding will get destroyed even without touching it.
But one question I have, we actually speaking, we are time traveling to the future every second, because every second we are moving forward in time. But to go more ahead in the future, you are saying that it should be faster than the speed of light.
I don't think it has to be faster than the speed of light. It just needs to be a significant amount if you want to go into the future by much. Like you don't need to go at the speed of light or faster than the speed of light, which is impossible other than a few theories that might be that might make it possible. But overall, you don't need to go at exactly the speed of light to time travel. You can go at 40% and it'll still give you a pretty significant it'll still be
just very
I
minute.
agree. It should be at least near the speed of light, but it won't be as significant, meaning you won't travel
Yeah,
that.
You will hardly notice the change.
No. Pranav, the speed of light is incredibly fast. So even going at 40% of it means that you're going really fast, and quite a bit of time will pass, not an insignificant amount.
When you're saying quite a bit of time, how much do you mean? Like 2 minutes or like how much?
I'm not sure about the calculations, but I'm pretty sure it's more than 2 minutes.
More than 2 minutes.
3 lakh kilometer per second.
Around 3 million meters per second.
Okay, that we time travel that much into the future. What will other people be doing when they're still stuck behind doing the old stuff? Like suppose we are
You're
muted.
now you are muted.
I heard that.
Okay, I got. So like if I say that even if we go in a long time ahead in future, what about the people who didn't travel? They'll be still doing the same work, right?
Yeah.
Yes.
Because there's only one human being at one place. There can't be more than one person at, like suppose you want to time travel to your own home, like for after 2-3 hours, and will you see yourself again sitting there doing some other work when you itself have time travel?
In cartoon, it will, but in real life, I don't know.
Only in, like we see in movies and all, that is possible. Like has anyone heard the movie called Adam Project?
Yes.
Yeah, I have
Yeah.
seen the movie.
in which he meets himself as a kid. He goes back in time and he meets himself. So, okay, how is it possible that there are 2 or more human beings of the same type in
If
the?
you travel to the future, then the place that you traveled from, the time that you traveled from, will become your past. And there is a past self. So the life continues in the past because now you're in the future.
But what is there in the future then? If everything is there in the past, when you go to the future, you'll see no one. Or what
No. People will evolve too. You've gone to the future. That's like, for example, 50 years ahead. People will have grown by 50 years by then. You're not traveling to a place devoid of people or things. Everything will have aged 50 years along.
So will you stay the same age?
Yes, because if you're going to the future and you're using Einstein's law of relativity in order to boost yourself to the future, yes, you will stay the same.
But everyone else is 50 years older.
Yeah, you will age by a little bit, but that all depends on how fast you're going. If you're going really fast at the speed of light, you're barely going to age at all.
Okay, suppose you go into the future. What about your own self? What about your parents? You will go missing and all those stuff. What about that?
So
We can also compare past.
If I'm just saying, if time travel was really possible, I would just try to skip the whole test and all and just get out of the test. But if you don't write the test only, how is it possible that you did write the test when you were not present in that time? Like when you travel to the future, you just to skip the test, but you won't be there to write the test only.
Exactly. You wouldn't have written the test because you've been skipped into the future. You would have, for all the other people, you would just been blipped out of existence, and then you would blip back after the period of time that you wanted to travel forward by.
So can I intervene at this point?
Yes, sir.
2 things I am intervening for. One is there are quite few of you who haven't spoken so far, so I want all of you to speak up. So those who have aired their views, I suggest you give some time for others to talk. But those who aired their views, I am putting few questions to them so that they can think about that and come back. So when you tell time travel, what is time? You are using time irrevocably with age. Okay, so you're telling Einstein's relativity, telling after some speed, if somebody is traveling, you will be aged less than the others. That is fine. Is that age? Is time age? Let us assume 2 people are there. One person goes and comes back. One person stays here. That person's age is less. Does that mean the person is time traveling? Time traveling means this person should not be in the present. This person should be living in the past. Is that what is happening? Or the person is living in the present itself with a reduced age? That means, are you telling time travel is as good as beauty parlor? You look younger, but you're living in the current stuff. Okay, so that is one thing I want you to think about it. Second thing I want to ask you, what happens to time if the universe starts shrinking? So now universe is expanding. What will happen to time if universe starts shrinking? So I want you to think about it. The third point, I want you to really think, what is time? So Swali gave a very philosophical answer by telling time is an illusion, Maya kind of stuff, right? That's what many people tell after a couple of smoking or ganja, by telling all world is illusion and Maya. But is it from a science point of view you're telling, or a ganja point of view you're telling? Also, you should be clear about it. So I want you all to think about what is time. Okay, and now, so all those who have spoken, you can think about these things to come back. There are more complex things when it comes to time. So somebody just mentioned, I think Swali mentioned about entropy and all those things. So those are important things. And there are things like symmetry of the molecules. So how Earth has evolved. So are you telling time is only for Earth? Or time is also there for universe? If there is another universe, is time applicable for that? If some other stuff is shrinking like a black hole, what happens to time there? So you think about it on a holistic perspective, okay? And those who haven't spoken so far, can they all come? If I'm not pushing you to talk, but if you are not getting chance, then you can talk.
Yeah. So like Pranav had said, does wormhole exist? So actually, wormhole does exist. No, we don't know if it exists in space, but mankind have made a small wormhole in a small magnetic wormhole at 2015 in Spain. So if we humans made sperm wormhole, there are chances that in the space also there may be a wormhole which we yet have not discovered, because our universe is keeps on expanding. So when it keeps on expanding, a new wormhole may form. So I'll say there are 99.9% of chances that wormhole may exist for me. That's all.
I'm saying that there is no time travel, but Google are all saying that there is time travel according to the physics law. Because I'm saying there is no time travel, because what is time? It is the when Earth moves. It because of the Earth move. No, at the time. Huh? So, if we want to do time travel or go into the past, we need to move the Earth once more like past. That's why I'm saying there is no time travel.
But scientists have tried wormhole, so they were like able to see the past for a millisecond. If I'm correct, scientists were able to see a wormhole for a millisecond only. If like you are saying wormhole does not exist, not wormhole, time machine does not exist, then how did those scientists find, how were they able to go to the past, like able to see a blink of it?
Oh, I don't know.
For me, like time travel to past is not possible, but to future, I think it is possible. So there's an experiment. So there are two persons, Jack and Jill. Okay, so Jack is traveling in train, and Jill is stationary in a platform. So Jack on the train has two mirrors like this, placed like this. So and the light will bounce between the mirror. Just imagine. Okay, so Jack will see the light moving like this, like vertically, right? So he sees the light bouncing up and down like 1.6 meters. But Jill on the platform does not see the light moving like this, because Jack is moving like this. Jill sees the light moving like in a triangular path, okay, because he's moving. So Jill sees the light moving more distance than Jack. So if Jack saw the light moving like 1.6 meters, Jill saw the light moving 4.8 meters. So, and as the speed of light doesn't change, like at no cost, speed of light doesn't change. Here, so speed of light stays constant. So the distance is different here. Jack saw 1.6 meters, Jill saw 4.8 meters. So as the distance is different, the time at they experience must also have been different to make the speed of light constant. So thus what they explained is that time must tick, or time must progress for people compared to people moving relative to each other. So as Ethan first said, the one moving faster will experience a slower time compared to one moving slower than them or just staying still. So that is proved by that aeroplane example and the ISS, Indian Space Station, International Space Station example. So that is what I have to say, that it is compared to the movements of two people. And I don't think that we can go to like past like 50 years before and change the way the things are being. So I don't think that is possible. That is only possible in science fiction movies. But I think that moving into the future is possible.
According to special theory and relativity, you can travel at the maximum speed, but there is a limit. It said that the velocity of light. Imagine you are traveling at the speed of light, then the time you travel will be zero. In the other case, you do not travel so that. Then it is possible that if you travel faster than that, then there are particles that travel as well. When you travel faster than the speed of light, your time travel backward. But this is a fiction, and that is why the theory of relativity says that nothing can travel faster than the speed of light. The dimension is not possible for us at the moment, but new technology will make it possible.
Like Manomi had said, nothing is faster than light, right? But there is something that is even faster than light. So Manomi said we cannot go at the speed. There's nothing in the world that is able to go faster than the light, but there is something that is able to go faster than the light. I like I found this when I was searching. So it is saying that darkness means darkness is like even faster than light speed. I don't know why it is faster than light speed, but light is not the fastest thing in our universe.
But light and darkness is connected, right? Like when light goes only, there comes darkness. So the speed at which light goes, the speed at which darkness will come. So both are like connected to each other, right?
And could I add something? Light doesn't go, you can't go faster than light in normal space-time. But if you manage to warp the space-time, you can go faster than the speed of light. And there's this experiment, I don't think it's they've done it anymore, but when there's this giant tube and it's supposedly has a giant, it's not made, but it's like almost like a theoretical experiment. It's got this giant tube and you've got a black hole inside that's compressed, and it should warp the space-time enough to allow faster than light travel.
Still, it's a theory.
Theory 100%.
I stated that it was a theory. I just wanted to say that it could be possible if the theory was true.
I would like if time travel would be there, but actually it mess up the whole universe if time travel is actually possible. And many bad people use advantage also for that.
But if if time machine was founded, it like no normal humans, like we all won't be able to even buy this time machine, because not even if it is like bad people, rich people, all the scientists will only make one time machine, or like in every street there will be only one for their use only. If we want to buy our personal time machine, if it is even made, we won't be able to like get it, like buy it, because it can cost like many money, like 10 billion, 20 billion. It can call like a quadrillion, all it can cost. And
Actually,
not
what
just
if
huh?
they make two or more time machines and sell it? What if they do that?
If to make one time machine only, we humans will have to struggle a lot. I mean a lot. Because to make a one time machine, you need many resources. For one resource, it will like 1 quadrillion, another 10 quadrillion. So they will like double this. So 1 quadrillion
Okay.
becomes 2
Okay.
quadrillion.
Okay.
10.
Can I interrupt?
Yes.
So we haven't yet made the time machine, right? So how will
Yes.
we know how much will be the one resources cost? How will we know?
Joan, actually, that is a good question. We have not made it, but it is an hypothesis that we may in future make it. We that time we may not exist that time. That
But
we
Abhinav, you should give the first time machine as Guru Dakshina to me for taking this class. The first time machine you make, you should give it to me.
Yeah.
Yeah, Abhinav?
Then you have to pay me like in $2 trillion.
Acha, then you should pay me for taking this class.
Yeah.
And your time machine, if the electrical malfunction happens and if it breaks up, my whole house, and I will be in trouble.
Not in trouble. It may form a wormhole.
Okay, it may form a hole. Whether there is worm in that, we will see. Yeah. Okay. Okay.
A black
So,
hole.
so interestingly, I just want to ask you this. See, somebody sitting in, let us say, another planet. Somebody sitting in another planet and watching our Zoom discussion, right? So all of us are sitting in different places. Ethan is in Dubai, Manomi is in Kannur, I think Anika maybe in Bangalore. I think different people here are sitting in different places, right? Yeah, but we all are seeing real time in this Zoom, right?
Yes.
Actually speaking, if you have to meet each other, you have to travel for some time.
Yes.
You have to travel maybe 5 hours, 10 hours to meet the other person. So because of this, the time is reduced. Now let us assume somebody sitting in Mars is watching this.
Okay.
Will they be able to see it real time?
Actually, no.
Okay. How much time they will take?
They will take by the distance of our planet Earth, and it may take 10 years.
No. If the mass is at the closest point towards Earth, it will take 6 to 9 months.
Depending on how much time light takes to travel, right?
Yes.
Depending on how much time light takes to travel, right?
But how will people in Mars?
Yeah, that's okay. That thought experiment. It's a thought. You can talk about time machine making and giving to me as Guru Dakshina. So why can't I talk about Mars people sitting and seeing our Zoom call? Yeah. Okay.
Yeah, sir.
Yeah. So.
Yeah, 100%.
Yeah. So see, the thing is, if you are seeing that, actually, let us assume it takes 24 hours. As a thought experiment, let us assume it takes 24 hours. So in this 24 hours, that means a person in Mars is seeing what is happening in Earth 24 hours behind. Continuously. What is happening in Earth? They are seeing 24 hours behind.
Because the light is not reached.
Well, let's assume the light takes that much time, whether Mars or any other place. So does that mean that they are living in our past? Because now whatever we are talking, they don't hear it now. They hear it after 24 hours. They hear, as of now, they see and hear what we did 24 hours before. Is it not that they are living in our past? Yeah, whoever wants to tell.
I disagree, because then, if we were to use that logic, then whenever we watch old footage of any event, we're living in that event's past, which is not true. We're consciously in this present, but we're simply looking at the past. We're not in the past.
Yeah, but that event is not current. The difference between seeing a past recording and this is current. The people in the earth, they see us and talking, or anyone can get into the Zoom call and meet us and talk to us.
Yes, they are
You could say time zones also, right?
Yeah,
Time zones would also vary.
yeah, of course. So that means it's in a different
Yeah.
time zone. But
For each person, it is there present.
yeah, but is time zone the same as this? Because time zone is slightly different. It's like when Earth is rotating.
see the future.
Yeah, see, when Earth is rotating, what is time zone? You are considering your time with respect to sunlight, right? So the first sunlight, probably you may call it as 6 a.m. The peak of sunlight, you may call it as 12 in the afternoon. Evening 6 may be the fading of sunlight. So if you can, morning 6 o'clock, you're just getting the sunlight. But so 5:55, if you board in a flight and travel opposite to the direction of Earth rotation, let us assume the flight takes 4 hours, and if flight is traveling faster than the rotation of Earth, then for the next 4 hours, you don't see the sunlight. If you would have been staying in the same position, in 5 minutes, you would have seen sunlight. But if you take a flight and travel opposite to the direction of Earth travel, that means towards the west, then next 4 hours, you don't see sunlight. That means you are 4 hours past. That is what is time zone. Opposite to that, 6 o'clock, you travel. So when you travel, let us assume 4 hours. So it will be 10 o'clock for you. But if you're traveling to the east side, you are coming closer to the sun. So that is what you call as time zone. Your position with respect to sunlight. This is not that. So let us take one thought experiment. Manomi is standing and dancing at her home. Okay, Manomi is standing and dancing at her home. So Swali is standing next to her house, so he can see Manomi is dancing. Okay, but this Abhinav is a troublesome guy, so we decide to pack him in a space shuttle and send him to space. So we pack Abhinav into a space shuttle, and the space shuttle goes. Let us assume half the speed of light. What is the difference between the Manomi's dance being viewed by Salih, who is standing next to her, and by Abhinav, who is traveling straight to the space at half the speed of light? What is the difference?
Can I say one thing?
You are being sent. You can't talk now. You have been packed and sent to space shuttle. Too much of trouble.
But can I still say?
Yeah, that is joking. Yeah.
If I'm going in half a speed of light, I will be disintegrated in not even a quarter way in the
So
start.
I'm telling thought experiment. It's a thought experiment.
You have to think it's possible.
Yeah. Think about it. What is the difference between the views of Swali and Abhinav?
Sir, Abhinav will be able to see Manomi's next dance show before Swali.
Is it so? Is it so? Is Abhinav seeing Manomi first?
I mean, Swali will see Manomi's dance move first. Later on, only will
Exactly. So Abhinav will see Manomi's dance movement after Swalik seeing only, right? Because the light rays, what is time for you? When you tell that you are seeing something, that is what your time. When you are telling that you are living in the present, what does it mean? When you open your eyes and look around, you are seeing what is going on. World Cup athletics happening, you can see that. Nivedita is sitting this side, you can see Nivedita. So some people tell that, oh, when I am walking, I am seeing that old person who died last month. You will tell they are living in the past, right? So those who are living in the present are the people who are seeing what is happening now, or they are sensing, or they are hearing, right? So your senses are experiencing the current world is what is your sense of time. Now, if Abhinav is seeing Manomi's actions later, that means Abhinav is a bit behind time. What if we increase the speed of Abhinav's space jet? He will see the things much, much later. What if Abhinav starts 1 second before Manomi starts dancing and he travels at the speed of light? Will he ever see Manomi's dance? He will not see, right?
No.
Because the first light ray of Manomi's dance, it can never reach the space shuttle, because space shuttle is traveling faster than light. It is like one guy is running and another guy is trying to catch up. So that is why when something travels at much higher speeds, for them, with reference to the place on earth or where from you started, with reference to that, they don't see the time moving. Right? They don't see the time moving. So that is the shift in time for them. So the concept of time you have to understand, one is with respect to rotation of earth, there is something called time zone. That is with respect to how much light you get. For example, if earth is revolving, let us assume we get a big JCB or a jack and take the earth and assume earth is in the equinox position. Just take it and keep it in the solstice position. Will time advance by 3 months? Climate will advance. Right? Climate will advance.
Time won't advance.
Yeah, so the concept of time is not as simple as somebody think, like it is with respect to watch or a calendar. So there is something called elapsed time, how much time you spend, how much things happening, and something called what you are sensing now. So Ethan, you can tell something you will tell.
I was just gonna say, technically the time will move if you're measuring relative to the Earth, but we usually don't. So we kind of really measure time relative to the universe, kind of the elapsed time over the universe.
Exactly. So whatever we are telling time in a daily parlance, it is actually with respect to Earth when we tell. And that is to do with your senses, what you see in the senses. So the point which I want to drive is the time whatever we are telling is very closely linked with light. When you see something, when the light comes to your eyes, when you see something, that is what is for you the time. So when something travels faster, that's why speed is linked to that. So let me ask you this. I hope most of you would have seen this picture of from James Webb Telescope. So some of these pictures are showing you a scenario which has happened few billion years back. Few billion years back.
Sir, isn't this from the Hubble Space Telescope?
I think this is James Webb. This Hubble's was not this deep.
This I
James Webb.
I think it was the Hubble, because this reminds me of the famous photograph that it took. I'm pretty sure it's the Hubble, but
okay. No problem. I will also check that. But the point is, like, you are seeing something which has happened few billion years before. So now when you see, the light which you see, light which you get from these places are something 4 billion, 5 billion. Now we are trying to see, can we get to see the light of universe's origin? Which means you are sitting here and watching what happened 13 billion years before. So is that time travel for you? I'm leaving it to you. You can think. Okay. And this is something which all of you spoke about, right? The what we call as twin paradox. So that's what we're telling. It's depending on the speed of this vehicle with reference to what is happening on Earth, how much this person will see will change. But again, when the person comes back, this person could be younger, but is this person living in the past? Actually not. The person is living in the current only, but the person looks younger. So elapsed time is different. And then this is what was the famous concept of time, which was presented by relativity. So I don't want to spend time, but that's how they tell the space-time relationship. For example, if this is space, whatever you tell, three-dimensional space, so this is where you are standing. So you can see only things or experience things where the light from those events are reaching to you. And so if this is the light which is coming, let us assume from this is where the sun is. From the sun, it takes 8 minutes for the light to come. So only you can see things. If something happens to sun now, you can't see for next 8 minutes. You can't see for next 8 minutes. After the 8th minute only, you will see what happened 8 minutes before. So that's what they call as the famous sun, the light cone, which means if you are an observer, if you are here, you are only part of the events which are happening in this light cone and this light cone. So outside this light cone, if you are able to be part of, that could be time that's possible only by time travel. So that is why many people are talking about this stuff, because this is a this is like a what do you call as a easy fix. Certainly you can't travel in space. Okay, so then in this Einstein and those guys at that time tell, what if the space is turned like this? Okay, so going like this takes time. So can you jump from here to here? It is like you are going to shortcut in a road. So you have to go like this in a road and go and come back. So you see these motorcycle guys just jumping this median and going to the other side. Haven't you seen that? So this is a concept like that. Well, not established so far. So right from Einstein's time, they were been proposing. So these are fictional stories. If it is there, it is possible. Like as of now, our understanding of our universe is it is like expanding in a plane. But what if in that huge plane, you can get a place like this? So instead of traveling all the way like this, can you cross the median and go to the other road, other lane? So that is simplistic concept, but solar theories, hypotheses. We don't know. We haven't found still. But something which people did, I think Abhinav or somebody told is, it's a concept. It's actually another commonsensical concept. So if you're telling,
warp drive.
Yeah, if people are telling, if you're telling space-time is the stuff, can you just expand the space-time behind you? And
I think,
yeah,
I think I was saying that the warping of the space.
Yeah. So somebody did an experiment in a very minute space. There are a lot of reports, huge excitement in scientific world, in a very micrometer kind of space, trying to create this, but the energy required for that itself is huge. But the simplistic concept is, if the space-time is what is determining the travel, can you just expand the space-time behind you, and can you just contract the one in front of you so that you can travel faster? Right? Because the person here takes more time to reach here because this is expanded. Now, for you to jump, it is like you are telling you want to jump from New Delhi to Mumbai. What if you wrap the road? The road you have to, let us assume it is 1,000 kilometers. What if you just make a chapati or a paratha roll out of the road and jump it? This is like telling that. So actually it is 1,000 kilometers, but I have wrapped it. And after I jumping, I am making it 2000 kilometers so that the guy behind is much farther. This is something like that. These are fictions, but
so it's kind
Yeah.
so it's kind of like the thing of like if you create a vacuum in front of you, the air will be pushed like behind and you'll go forward. It's kind of like that, or like an inchworm. It's more like an inchworm. It contracts and then expands, right?
yeah, it contracts and expands not like automatically, like you are thinking like this methods. If space-time, for example, like we know there's an inflation phase, like the explanation for the size of universe, as I told the other class, which is 94 billion light years, and the whole universe story itself is only 13.8 billion years. So in 13.8 billion years, light cannot travel. You can't have 94 billion light years of a space. So that is because they have an expansion. They have theory that of an inflation. So like Abhinav told, something which cannot travel more than light within this frame, within this space-time frame. But space-time itself, it seems to have traveled faster than light, because that is a frame. Okay, so that's a bit of a complicated concept. But as of now, so this is something which there was huge news a couple of years back that there was a small experiment which did in a very small space like this to do this. But the simplistic theory is a commonsensical theory. You can't travel faster than light. So what you can do? Can you go shortcut? Or can you go compress this? So things like that. Okay. So this I would tell the last one, which is not exactly regarding to time travel, just to create a curiosity. That is a puzzle among scientists. There is something called quantum entanglement in quantum mechanics. This is what Einstein termed as spooky action at a distance. So, which is a bit tricky. Like there is something called spin of an element, a big element of particles. So they say like if couple of particles who are having as a pair property, so they, which is what called a superposition. So if one of it is in one position, one spin, and another one would be in opposite spin. So in the first one, you don't know what is its spin. So if its spin changes, the spin of the other one will also change. So like you tell Siamese twins, if one twin cries, the other twin cries. Okay, people tell the story of that, right? So if one twin is in US and another twin is in UK, also if this cries, another one cries. We don't know, maybe it's stories. But this is like that. So how the communication happens, it happens like that. Telepathic or things like that, more of fiction. But this is not fiction, this is true. It's a bit more of advanced things are there. But just go and browse and search. If you want to just kick up your brain, just think about.
Is the answer found out for this question?
Yeah, quantum entanglement, there are a lot of explanations. You just go and see some videos of science explanations. There are a lot of explanations. It's a true thing. Quantum entanglement is a property of quantum mechanics. It's a true thing. Just go and search that. But the thing is, action happens at a distance also, but it's not an action actually which is happening. It's like if this is so, other one is opposite. Then if this is changed, then other thing changes. It's a bit of a tricky kind of stuff. Just go and read this. Anyway, these are more fictions, less action, interesting topic. This is what we'll do on Wednesday. What I'm expecting you guys to come is what are the major pressing issues in front of science today? What is that our scientists are being bothered about? Where are they spending their time in? What are the kind of experiments? What are the kind of hypotheses they are trying to prove? What are they behind? Key 4, 5, 6 things. That means when you grow up, those will be the kind of areas probably you may be working on if you are continuing in the field of science.